Hello everyone and welcome to MV Tutors. I'm Solo and I'll be looking at the introduction of organic chemistry with you guys today. Alright, so what is organic chemistry? It is the chemistry of carbon atoms in living and non-living systems. Now, there are carbon atoms that you get elsewhere which are inorganic, okay? For example, you would get like carbon dioxide, carbon monoxide, carbonates, or whatever. We're not going to focus on inorganic compounds today. We're just looking specifically at the organic ones. All right, and the organic compounds that we are studying in matric, they consist of oxygen, okay? They consist of oxygen. They consist of halogens. Okay, by halogens I mean if you look at your group 7 elements, you can have fluorine, iodine, chlorine, and bromine. Those are the main ones that we look at. Okay, so oxygen, we get halogens, which are mainly represented by X, and then we get the carbon, okay, atom itself. And whenever you have carbon attached to another carbon and other carbons and so forth, we call that catenation. Okay, so catenation really is just carbon atoms forming chains together or forming rings, but basically it's carbon attached to other carbons. All right, so I'm just going to say CC here just to say carbon is bonded to other carbons. So why is it that when we look at organic chemistry, we focus so much on carbon? Well, carbon is sort of like a special element in this case for organic chemistry. And carbon is on group 4. Remember on your period table, the columns of the period table represent groups. Okay, and then the rows represent periods. So carbon, okay, carbon is on group 4A. All right, and since it's group 4, it means that it has 4 valence electrons. Okay, so there you have your carbon structure. All right, and if you're gonna draw the Lewis dot structure, okay, carbon there has 4 valence electrons, so those electrons are available to pair with other elements. Okay, and since, did I mention hydrogen? No, I didn't, sorry. So yes, in organic chemistry you have compounds like oxygen, halogens, carbons, as well as hydrogen atoms. All right, and if I were to look at the Lewis structure where carbon combines with hydrogen, for example, to form hydrocarbons, you would have hydrogen atoms sharing the electrons with the carbon atoms. Okay. And why do we put 4 hydrogens around those 4 valence electrons from carbon? Well, basically we want to fulfill the octet rule. Okay, so with the exception of hydrogen and helium, each element basically on the periodic table of elements, well, not all of them, but they want to fulfill the octet rule, meaning you want to have 8 electrons around the element that you're looking at. So for example, this cross here represents an electron as well as the dot, so you'd have 2, 4, 6, and 8. Okay, so 8 electrons are surrounding carbon. So now your octet rule is adhered to. All right, so yeah, that is carbon from group A, 4 valence electrons, and it forms covalent bonds. Okay, so through the structure, the Lewis structure, we can see that it forms covalent bonds. Okay, and covalent bonding is pretty much the sharing of electrons. So hydrogen comes with this 1 electron, and you have carbon with this 4 electrons available. And yeah, they share. It's different from ionic bonds where the weaker element with the least ionization energy, it gives away its electron, and then one with the highest ionization energy takes it or accepts the electron. So then you start having elements that have charges. Okay, maybe you'll have hydrogen. If it gives away its electron, it will be positive. Okay, let me rather not put brackets inside because that means something else. So you'll have hydrogen there, which would be now positive because it has more protons than electrons because it donated its electron. And you probably have like oxygen, let's say 2 minus. Okay, if you have two hydrogens that are bonding to the oxygen, it gives away 2 of its electrons. So now oxygen has 2 extra electrons. Okay, it has an excess of electrons. So ionization, okay, so ionization or ionized bonds, that is what happens when you get ionized bonds. But if you have covalent bonds, it's more of the sharing of electrons. And another way of indicating the Lewis structure for, let's say, the carbon-hydrogen atom, known as the hydrocarbons, you can represent with the line. And this line basically indicates that there are 2 electrons involved. Okay. And again, the octet rule is adhered to. Okay, so yeah, carbon, it forms covalent bonds. It has 4 valence electrons available to bond with other atoms as well. And yeah, so when we have carbon, okay, so yes, carbon forms covalent bonds with either hydrogen, oxygen, the halogens that we discussed, and also other carbons, which we then talked about and said that process is called catenation. All right, and through the process of catenation, you can get 3 kinds of structures. You can get chain structures. Okay, where you have carbon bonded to another carbon and another carbon and so forth and so on. Okay, you can get branched structures. So there's still chain structures but are branched. Okay, so I will say chain branched structures. Okay, that is when you have, still going to use the same number of carbons as above, so 4 of them. So you have your chain, and then somewhere along the chain you have a branch. Okay, all right, because carbon has 4 valence electrons, actually should indicate that the other atoms bonded to it. So around every carbon atom you have, there should be 4 bonds there. Okay, so you'll have that as well. Unless if you have double bonds and triple bonds. Oh yeah, carbon can also form double, single, and triple bonds. All right. So yeah, you have the chain structures, then you have the chain branched structures, and then you can also have rings. Okay, so carbon rings. Is that the right word to say? Yeah, you could have carbon rings. They're normally referred to as aromatic compounds. Ooh, carbon rings. Or you could say aromatic compounds. Those are responsible for the very nice aromatic smells. Okay. So yeah, you would have a ring structure where basically it's kind of like closed. So I'm just going to use 6 carbons there. They're all bonded to each other. Okay, and because carbon forms 4 bonds around it, just remember to indicate that as well. So yeah, and that is how it is. Okay, so yeah guys, if we look at carbon or rather organic compounds. They're like more than 10 million types, okay? Each one has their own name. Each one has their characteristic physical properties like its boiling point, melting point. Each one has its own chemical properties, all right? And to study each compound, organic compound, is near impossible. So what scientists have done, they have tried to group together certain organic compounds based on their their structure, okay, based on the chemical properties and physical properties. Just like on the periodic table, when we have a certain trend, if you go from left to right on the periodic table, the ionization energy increases. If you go from the bottom to the top, again, the ionization energy increases. If you go from the top to the bottom, the atomic radius increases. So if you go from the left to the right, the atomic radius decreases. Okay, those are the general trends, okay, in a periodic table. Where you have your groups, you have your periods, and you can describe certain properties based on the trend that you are seeing. So they also saw trends with organic compounds, and in that way they were able to group them so that it's easier for us to study today. Okay, so then we look at this term called the homologous series. Okay, so they used homologous series as well as functional groups to be able to help us to group them together and study them, and it'll be simpler instead of studying individual ones. And I'm just going to define now what the functional group is as well as the homologous series, and we'll end the session there for today. Okay. Okay guys, so what is the homologous series? It is a series of compounds that have the same general formula and the same functional group. Alright, in the next video we're going to talk thoroughly, or maybe briefly at the beginning, about these homologous series. Okay, for example, for now I can just mention the alkanes or the hydrocarbons. Okay, so for the hydrocarbons you have alkanes, alkenes, and alkynes. Difference between them is just the alkanes have single bonds, alkenes have double bonds, alkynes have triple bonds. So because of that, each homologous series has its own general formula. The general formula for alkane will be CnH2n plus 2. The alkenes will have CnH2n, and the alkynes will have CnH2n minus 2. Alright, don't worry about it for now. We'll sort it out in the next video. And yeah, the same functional group. So the functional group, you just take maybe just a single carbon and see how it bonds with other, or maybe two carbons, and see how it bonds with each other. Okay, for example, like I said, the alkane, they have single bonds. Then you have the alkenes, which have double bonds, and the alkynes, which have triple bonds. But yeah, we'll sort it out, like I said, in the next video. So that is your homologous series. Your functional group, okay, that could be a bond, an atom, or group of atoms that determine the physical and chemical properties of organic compounds. All right, so yeah, maybe let me just do one example. For example, let's look at alkane. Okay, so your homologous series is alkane. I'll just say that is your homologous series. Okay, that is just HS, homologous series. That is the alkane. If you look at the structure of alkane, okay, let's just look at two carbon atoms. Okay, this is an alkane, forms part of your hydrocarbons, so it's carbon atoms bonded covalently to hydrogen atoms. Okay, so you have maybe, I'm just going to look at two carbon atoms, all right, and they are bonded to hydrogen atoms. All right. All right, so that is the alkane. Now, when I spoke about the general formula, here you see the general formula for alkanes is CnH2n plus 2. All right, so as you can see, we have two carbon atoms, right? So that will be substituted by 2. And then your hydrogen atoms. So we say 2 times the 2 N, okay, plus 2, all right? So basically you'll have C2H6, okay, because 2 times 2 is 4, plus 2 is 6. And if you count it, so you have 1, 2, 3, 4, 5, 6 hydrogen atoms, all right? So there we have our homologous series. Okay, I'm just going to put the HS again there. That is your homologous series. Now, what is the functional group? So what I have drawn here, okay, this is your functional group. So you know when you have an alkane, there are certain properties, like the physical and chemical properties, that are unique only to the group of alkanes. Okay, if you go to alkenes which have double bonds, again you only have properties that are unique to that homologous series. Okay, so the functional group really speaks to the chemical and the physical properties. All right, sorry for the sound, let me pause quickly. Right, and we'll also get to the naming of these homologous series and functional groups. All right, but in this case here, where we have 2 carbon atoms coming from the homologous series of alkanes, this would be called propane. Okay, so 1 carbon would be methane, but 2 carbons is propane. So yeah, we have propane. This is the general formula, C2H6, and this is the functional group. And yeah, this ends our video now for the intro. I will get into more details on the next one. Thank you.